Last time we introduced the idea of integration by substitution and gave you a problem to evaluate. That problem was an integral of 3t squared times a plus 3t cubed to the 1/4 power integrated over time. So you know that if you want to use integration by substitution, you pick some variable, some part of this integrand which you can refer to as u, and then you calculate du dt to get rid of the other t terms if you can. And if you can, this turns out to be a useful method for obtaining the integral of complicated integrands. So how did you do? In this problem, what we can, it's kind of obvious what u would be, and it usually is in these cases. We've got 8 plus 3t cubed here inside the radical, and so we're going to let u equal 8 plus 3t cubed. Then our du would be, we're calculating du dt of 8 plus 3t cubed, and we see that du then would be 9t squared times dt. We see the t squared dt up here. We see a 3 over here. So when we replace du with 9t cubed dt, we need to divide that by 3 in order to get back to this integrand when we substitute back in. So having done that, you have an integral then that's a little bit easier to guess what the integral is. An integrand here, you have a little bit easier time of guessing what the integral might be. And we could start again with, not very creative, but we'll just let it equal u to the 5/4 power. We know that we're going to reduce it by 1 when we differentiate, so we'll get the u to the 1/4 back. How does that go for us? So if we go through the test and differentiate this du to the 5/4 with respect to t, well, it's actually a chain. We're differentiating u to the 5/4 with respect to u. We get 5/4 u to the 1/4, and then we have to continue with the chain to differentiate du with respect to dt. And in the end, since we've already figured out what du dt is up here, we just substitute back in. We get that this result that we obtained from this guess gives us 15/4 3t squared times 8 plus 3t cubed to the 1/4. We have this extra factor in here of 15/4. We've got to get rid of that. What's the easiest way to do that? Well, we would expect the easiest way to get this result to look like this would be to multiply our guess by 4/15. So in this case, in our first guess, we didn't get the integrand back. Differentiation did not return the integrand. And if we introduce that factor of 4/15 into our guess, we would get 4/15 times 15/4. So these are going to cancel out. And then we get exactly what we're after. That makes it work. We get that the integral of 3t squared times 8 plus 3t cubed to the 4th is equal to 4/15. Necessary factor here to get rid of this, times 8 plus 3t cubed to the 5/4. And there's our familiar friend, the constant in this indefinite integral. So for additional practice, not just for integration by substitution, but also using our exponential rules, the power rule, the special case for the power rule, and integration by substitution. Take a look at these four integrals. and pause the video, work through them. So I assume you took a few minutes and worked through these, and let's just quickly go through the results. On the first one, we end up with a factor 1/2 when we differentiate the exponent. We have to get rid of that since we don't have a factor 1/2 out here as a coefficient before the exponential function. So we get 2e to the 0.5t. For 4t squared, this is an easy application of the power rule for integration. We know that we're going to increase this by 3. We're going to have to divide by 3. So when we differentiate this, we get 3t squared. The 3's cancel out. We get the integrand back. But this is a definite integral and evaluated over the range from -2 to 4. You should get 96. This example is just to remind you of the special case. The integral of 1 over t, 1 over x, 1 over anything is going to, not 1 over anything, but 1 over t is going to be equal to the log of t plus c. Fairly straightforward. On this one, what did you get? Did you come up with -156, 7x squared plus 3 to the -4th power? Well, integration by substitution helps in this case. We can let u equal this quantity inside the parentheses, 7x squared plus 3. And when we differentiate that and solve for x dx, we get that x dx is equal to du over 14. And we combine that and we get that this, using a substitution for u, gives us the integral du over 14u to the 5th. So now if we guess that the integral is u to the -4th and differentiate that to check it out, we get -4u to the -5th, which is not equal to 1/14th u to the -5th, which is what we have up here in the integrand. So we have to introduce a factor of -1/56 to get this result up here. That's going to cancel the negative sign. 4 over 56 is going to give us 1 over 14. And we're home free. Next time we're going to talk about integration by parts. And integration by parts comes from the product rule for differentiation, where we have the differential of two functions duv. Product of two functions is equal to u times the differential of v plus v times the differential of u. And we can manipulate that into this integral form. And I'd say for next time, take a look at this particular integral and see if you can figure it out using this approach. Next time then.